Hello friends! These courses are more than just listening. Let's turn them into a fun and engaging virtual discussion where we can learn these simple concepts together. Get ready to be inspired, ask questions, and have a blast. We all love ice cream, right? Let's take an example from an ice cream seller who has collected 10 data points for us. He recorded his sales figures for different weather conditions and shared them with us. This table shows how many ice creams were sold at different temperatures. Look at it carefully. You'll notice that as the temperature increases, the sales figures also go up. At 18 degrees, the ice cream seller sold 120 ice creams. But when the temperature reached 25 degrees, he sold almost 250 ice creams. Please pause the video now and take a good look at the table. Let's plot the data points together. On the x-axis, we'll put the temperature values, and on the y-axis, we'll put the ice cream sales. If you look carefully, you'll see that the sales figures go up as the temperature increases. Let's calculate some simple statistics. We'll find the average, mean, of all the temperature values and the average of all the sales figures. On the right-hand side, you'll notice that the mean temperature is 23.8 degrees and the mean sales figure is 233 ice creams. Isn't that simple? All right, now let's take the previous graph and draw two lines. One line is x equals to 23.8 and the other is y equals to 233. These grey lines in the middle will indicate the average temperature and the average sales. These lines will divide the graph into 4 quadrants. The first quadrant, the second quadrant, the third quadrant, and the fourth quadrant. You can see that the first and third quadrants have more data points compared to the other two. Let's choose a point from the third quadrant with an x value of 18 and a y value of 120. Now, let's find the difference between 18 and 23.8 for x and between 120 and 233 for y using the point 18, 120. You'll get two numbers, 5.8 and 113. Since both numbers are negative, when you multiply them, you get a positive result. Take some time to think about what happens with a point from the second quadrant. In this table, I've calculated the values for all the points. Pause the video and check each point one by one. Look carefully at the last column. You'll see that all the values after multiplication are positive. So, if we add up all the numbers in the last column, the total sum will be a positive value. Now let's look at a different data set. In this one, we've noticed that ice cream sales go down as the temperature increases. Maybe people are becoming more health conscious. Check the mean value of the ice cream sales units. It's much lower than in the previous dataset. Let's plot this data to see it visually. In this graph, it's clear that as the temperature increases, the sales figures are going down. I've drawn lines at x equals to 23 and y equals to 115 for your reference. And the grey lines show these points. Now, let's take 2 points from the second and fourth quadrants. You'll see that the product of x minus 23, e minus 115 will be negative, no matter which points you choose from these quadrants. So, I've shown you that the second and fourth quadrants have more data points. Since the product of x minus 23, 8 and y minus 115 for these points will always be negative. Their sum will also be a negative value. Here's a table with all the calculations. Check the last column. The sum of the values is negative. Now let's recall our findings. If the x and y values have a positive relationship, meaning y increases as x increases, then the sum of the product of x minus x bar and y minus y bar is positive. Alternatively, if y decreases as x increases, then that sum will be negative. If x and y have a positive relationship, there will be more points in the first and third quadrants. If the relationship is negative, there will be more points in the second and fourth quadrants. Based on all our observations, we can think of a formula using the sum of the product of x minus x bar and y minus y bar. This is called the covariance of x and y. If the covariance is greater than 0, then there is a positive relationship. If it is less than 0, then the relationship is negative. Covariance is highly affected when we change the units of measurement. To make it more reliable, we can standardize the data, which gives us a formula called the correlation coefficient between x and y. Let's make some observations about correlation. It always falls between -1 and 1. Just like covariance, if the correlation coefficient is greater than 0, then the relationship is positive. Otherwise, it's negative. It's important to note that if the correlation is 0, it doesn't necessarily mean that y and x are unrelated. It simply suggests that they aren't linearly related, as the correlation coefficient measures only linear relationships. In other words, the correlation can still be 0, even if y and x have a non-linear relationship. Thank you for completing the course. If you have any questions, please comment below, and I'll do my best to assist you.